Dear students, in the previous two sessions, I have taught you about the definition of the differential equation and how to find the degree and the order of the differential equation, and the first method, that is where the variables could be separated, we have worked out some problems. So, in this session also I am going to work out some problems which are solved using this particular method, which is known as the variables separable method. That means what we did in the previous session, we take x and dx together, y and dy together, then integrating we get the general solution. The first problem being secant square x into tan y into dx plus secant square y into tan x into dy is equal to 0. Now look here, I told you already we have to separate the variables. In the first term I am having secant square x and dx here. So tan y, that y term is not wanted here. Similarly tan x is not wanted here. So here we have to eliminate this, here we have to eliminate this. So we can do that, when it is in the numerator, you know that you have to divide. You can do that both the operations together. That means that divide by tan x into tan y. Of course, one advantage is the right hand side we are having 0. So by dividing that value, the right hand side remains the same here. Divide by tan x into tan y. Here tan y is cancelled, tan x is remaining. That is secant square x divided by tan x into dx. Similarly, tan x is cancelled and we will be left with secant square y divided by tan y into dy, that would be equal to x. Clearly you can see that both x and y have been separated here. Now let us go for the integration, that is integral 1 divided by tan x into secant square x into dx plus integral 1 by tan y into secant square y into dy. I told you, when as soon as you write the integral sign, make it a habit to write the constant. Here you can take any constant. Here I am taking, generally I have taken c here, I am taking here k. The reason is, by looking at this function, I could say, next we come to what method of integration we have to adopt here. Look here, secant square x is the derivative of tan x, secant square y is the derivative of tan y. That means that by taking this as u, the whole of the numerator becomes du. Similarly, if you take this as v, that becomes dv. In other words, I am making use of the substitution method here. So that means that 1 by t dt, 1 by like that, it becomes a logarithmic function. So that whenever we come across logarithmic function, if possible we make use of the law of the logarithm, the first law, the second law or the third law. So here afterwards, case anyway it is an arbitrary constant, I can take it as afterwards some log of c, so that we can make use of the law of the logarithm. Now here how can you say integrate now? First let me make a substitution. Let the tan x be equal to u. When tan x is u, naturally secant square x dx would be equal to du. First one. The second one is, you take tan y, because there are two variables here, take it as, it is left to your choice, t or u, anything you can take. It becomes secant square y dy would be equal to dv. Now the integral now could be written as 1 divided by u into dv du plus 1 divided by v into dv, that is equal to some constant. Now what are the integrals here? It is log of u plus log of v. Now k I am writing it as log of c, just to present the answer in a better way, in a proper way. Now you can use the law of the logarithm. It's of the form log m plus log n, which is equal to log of m into n, the first law of logarithm. That is log of u into v is equal to log of c. So log of a function equal to log of some other function means that logarithmic function can be eliminated and write it as u into v is equal to c. Now what are u and v here? U and v are tan x and tan y. So tan x into tan y equal to c is the solution. Okay. So I told you already in the previous session that in all the problems we may not be in a position to use you cannot express in a simpler way. Wherever it is possible, we may have to use the law of the logarithm or some other rule. If it is possible to present the answer in a simpler way, you can always do that one. Okay. Now, let us move on to the next problem. Okay. Here again, I consider some function where this dx and dy and x and y are mixed up, where we can separate them by doing either multiplication or division. It depends upon the problem that has been given. Suppose we have been given dy by dx. Now, first take dx to the numerator by multiplying. If already dx and dy are separated, see that x and dx and y and dy are together. Take the next problem. Here it is y into log y into dx. First one. Next, minus x into dy is equal to 0. When the right hand side is 0, it is easier to do the division. Look at the terms here. See, this is purely a y function we are having with dx, x and dy. So here x should go with dx and y and log y should go with dy. How is it possible? You can do the division here. Divide by whichever term is not wanted here, divide by that one. X is not wanted, y is not wanted, and this is log y. Or you can do in different steps. First you divide by x, it comes to this position. Then divide by y into log y. Division means I am taking all of them together. So one step is skipped here. Now y and log y are cancelled. What is remaining? It becomes dx by x. Similarly, x is cancelled and what is remaining? It is dy divided by y into log y. Of course, right hand side being 0, it is easier to do this type of calculation. Now let us go for the integration. Integrate. It is integral 1 by x into dx minus integral 1 by y into log y into dy. Here also take some constant. Even you can take c also, no problem. As in the previous problem, I took k, then I changed over to log c. Or you can take c here, you can write it as log k, because that is an arbitrary constant. Any constant c or k you can use here. Generally we use c here. Okay. Now look here. This is directly, it is a simple function. The integral is log x, whereas here it is not a simple function. We are having y into log y. Now take here, we can write y here, 1 by y dy. Now here you have to make use of the substitution method. Taking log y to be t, 1 by y dy becomes dt. Only the first one you need not do, because it is a direct problem, direct function we are having. So here we write, let log y be equal to t, then we have 1 by y dy would be equal to dt. So the integral now could be rewritten as 1 by x into dx minus integral 1 by t into dt, that would be equal to k. Now clearly you see that it is, both of them are logarithmic functions. It is log x minus log of t, that is equal to k. Now in the previous problem we had the positive sign. So I made use of the first law of logarithm. Log of m into n is log m plus log n, whereas here it is log m minus log n. That is the second law of logarithm. How do you write this one? It is log of x by t, that is equal to, now you can write that also as a logarithmic function. So that implies that x by t is equal to c. That is x is equal to c into t. Now what is t? You write t is log y, that is x is equal to c into log y is the solution. See, I told you in all the problems we cannot get a simple function, simple solution here. If it is possible, you try to do this one. So you can write x is equal to c into log y is the solution. Now let's move on to the next problem. In the next problem, again again I may have to make use of the substitution method only. But here we are having a combination of the exponential as well as some trigonometric function. The next problem is e to the power x into tan y into dx plus 1 minus e to the power x into secant square y into dy. Secant square y into dy is equal to 0. Okay. Now again look at this one. We are having two different types of functions. Of course, both the terms of this one are involving the x term as well as the y term. E power x is there, dx is there. So tan y we want it with the dy. Similarly here, see 1 minus ex e power x is there, which has to go with the dx, and the secant square y should remain with the dy. So here we have to divide to make it completely a term containing x here, we have to divide this by tan y, we have to divide this by 1 minus e power x. Let me do the division together. Divide by tan y into 1 minus e to the power x here. So when you divide, this is cancelled, this remains, that is e to the power x over 1 minus e to the power x into dx. Now plus here 1 minus e power x is cancelled. So what is remaining there? Secant square y divided by tan y into dy is equal to 0. Again, because the 0 is on the right hand side, it is easier for us to do this, adjustment of the terms here. Now look here, look at the terms. When you look at the terms, you will know what method of integration we have to use. 1 minus e power x I am having, numerator is e power x. Suppose you take this as t, the numerator becomes dt, the derivative. Similarly, when you take tan y to be equal to t, the numerator becomes a derivative or dt. Therefore, here also I am making use of the substitution method. What is a substitution? When there are two here, I am taking u and v. When there is only one substitution, I am taking it as t. It means the same here. Let 1 minus e to the power x be equal to u, then minus e power x dx equal to du, or we are having only e power x into dx would be equal to minus du for the first term. For the second term, it is let tan y be equal to v, then secant square y into dy would be equal to dv. Now let me do the integration. Let me use the integral sign. Integral e power x over 1 minus e power x dx plus integral secant square y into dy divided by tan y. Here also I am taking the constant to be equal to k. The reason being, you observe in both the cases again we are getting a logarithmic function. Let me make the substitution. 1 divided by u into minus du plus 1 divided by v into dv, that would be equal to k. So 1 by u and 1 by v, the integrals are log of u minus log of u plus log of v, that is equal to k. Let me write in the proper order. It is log of v minus log of u, that is equal to k. I just want to take the positive term first. So as in the previous problem, in this problem also I am making use of the second law of logarithm. So I can write it as log of v by u equal to, now write it as a logarithmic function. That implies that here v by u can be written as c, or v is equal to c into u. Now what are v and u? We have to write. V means it is what we have taken, it is tan y. Therefore you can write tan y would be equal to c into 1 minus e to the power x. Now this is the solution of this particular equation. So here wherever it is possible to write the answer or to express the answer in a simple way, we can use that method. So that is possible in maximum number of problems. It is possible only when we come across the logarithmic functions, okay. Or in one of the problems I used in the previous session, we could make use of the inverse trigonometric function also, if it is there, okay. Otherwise, wherever only, otherwise in all the problems you cannot express in a very simple way. It depends upon the terms that have been given, it depends upon the integrals what we are getting in a particular problem. So in all these problems, I have just calculated the general solution. The instruction was find the general solution. General solution means, as I told you, you do the integration, you will be getting an arbitrary constant, C or K or whatever may be that one, keep it as it is. Now what do you mean by particular solution? Particular means in this one, when the problem is given with that, they have to specify about the values of x and y which have to be given after getting the general solution. So after getting, till we get that general solution which involves C, the procedure is same. After getting that general solution, whatever values have been given in the problem, you have to substitute for x and y. Naturally, C can be evaluated. So after getting the value of C, we can substitute again in the general equation, general solution. Then if it is possible again to do some simplification, we can go for simplification. Otherwise, just substitute the value of C and you get the answer. So the instruction now is find the particular solution. First problem, find the particular solution. Here, understand this problem carefully. It is little bit different. Cos of dy by dx equal to A. What does A represent? What does A mean? It is a real number. A belongs to the set of the real numbers. Now, y is equal to 2 when x is equal to 0. Like this, it would be specified in the problem. Okay, it would be given in the problem. So you have to write that, you have to copy the values of x and y also properly. So here these data y equal to 2, x is equal to 0 will be utilized only in the last step. Look at the function here. Cos of dy by dx equal to A. Okay. Now here as it is, I cannot separate the variable. That is a method we are following here. So I am using the definition of the inverse trigonometry function. That is, how could you write dy by dx here? You can write it as cos inverse of A being a real number here. Now you can separate the variables. See, we don't have any other term containing x or containing y. Only dx has to be taken to the right hand side. So I can just write it as cross multiply. Okay, in all the problems I cannot use that word cross multiply. Here only dx is there. Let me take it to the right hand side. That is, dy would be equal to cos inverse of A into dx. Now clearly we see that dx and dy, that is x and y, are separated. But for dx and dy, we don't have any other term containing x here. Now go for integration. Integrate, you have to write here, integral dy, cos inverse A being a constant remains outside the integral sign. So cos inverse A into integral dx, I told you immediately you have to write the constant C here. Okay. Now integrate. What is the integral of dy? It is y. And write cos inverse A as it is, and then integral of dx is x, then C. Now take it as result 1. Why I am giving a number for this one is, after substituting the values of x and y, we have to write back the value C in this equation. So I am just giving a reference to that one. Now in this one, put the values. Put x is equal to 0, y is equal to 2 in 1. So by giving a number, we will be having a reference here. The left hand side y is 2, that is equal to cos inverse of A, you write as it is. For x, what is the value? X is 0 plus C here. Now this being a constant here, 0 into anything is 0 plus C. What does it imply? C is equal to 2. So these values of x and y are given only to find the value of C, which is a arbitrary constant. Now this value of C equal to 2 should be substituted in 1, result 1. Now write here, substitute for C in 1. Okay. So we have y is equal to cos inverse of A into x plus 2. See, look here, cos inverse of A, see, only to get the value of C we have done this one. Afterwards you have to write y and x only. This is the solution here, particular solution. Now in this problem I am making some alteration in the answer because the problem is given. It may not be necessary, it is not necessarily you have to do that one. You can stop at this stage also. But in this particular problem, since the problem was given as cos of something, if possible I want to express the answer or the solution also in that form. How can you do that one? Take 2 to the left hand side, that is y minus 2 equal to cos inverse of A into x. Okay. Now this may not be absolutely necessary, I am just trying to write the answer in a better way in the form where it has been given in the problem. Now that is y minus 2 divided by x equal to cos inverse of A. There I made use of the definition of the inverse function. Here also I am making use of the same thing, that is taking this inverse like this, it is cos of y minus 2 by x equal to A is the solution. Okay. So the function was, the equation was given as cos of dy by dx. I am expressing that in the same form, but otherwise if you stop here also the answer is correct. So I told you already in the previous session why we use this method is, so why we want to simplify that is because in some particular examination or wherever you come across, no, you may have an answer, you may have got an answer here which may not be present in the choices. So in that case, no, you should be in a position to know how to simplify, how to rewrite the answer in another way. For that purpose I am writing. Otherwise, if they ask you only the solution, this would be enough here. Okay. Now, this particular solution, calculating the particular solution, instead of giving the data directly like this, yx is equal to 0, y equal to 1, x is equal to pi by 2, y equal to 0, something like that. Instead of that one, there is another way of giving the data. Data is given but not directly. Here you can see it was given directly, isn't it? But instead of giving the data directly, it can be given in an indirect way. So you have to analyze. In one of the earlier examination, the problem is given like this. Of course, it is again a 3-mark question only. So let me try that type of problem also, so that by chance you come across that in the examination, you will be in a position to solve the problem. Now it is like this. Find the equation of the curve passing through the point 1 comma 1 whose differential equation is x into dy is equal to 2x square plus 1 into dx. Of course, one condition is given, x is not equal to 0. So, x into dy equal to 2x square plus 1 into dx here, x being not equal to 0. It can take any other value but for 0. See here, I told you that whenever we do the integration, or when in this case when you are doing the integration to find the solution of the differential equation, we will be getting a curve, isn't it? See, when the equation of a curve is given, we differentiate, we get the differential equation. When the differential equation is given, we do the integration, we get back the curve here. So whenever you do the integration, need not be in differential equation. Whenever you do the integration, we are getting the curve back here. So, differentiation means given the curve, you find the derivative. Integration means given the derivative, you get back the function or get back the curve here. So, the data what I gave in the previous one, x equal to 0, y equal to 2, it is given in another way. Look here, find the equation of the curve passing through 1, 1, whose differential equation is given by the axis. So, when you do the integration, when you find the solution here, we always get a curve here. And how it is, the curve, that particular curve which we are going to calculate is passing through 1, 1. So, instead of giving the data, put x equal to 0, y equal to 1, here 1, 1 means when x is 1, y is equal to 1. So, it is given in indirect way, okay. So, it can be given as a statement problem also. So, you have to separate the variables, same procedure, instead of giving the data directly, it has been given in an indirect way. You have to remember this one. So, what I do is x into dy equal to 2xy. So, we do not have any term containing y, only x has to go to the right hand side and it is in the numerator divide by x. That is why it has been given as x not equal to 0, because division by 0 is not defined. So, when you divide dy equal to, there are two terms here, divide both of them by x, that means 2x square by x plus 1 by x into dx here. Now, let me write the simplified form. Dy would be equal to 1x is cancelled, 2x plus 1 by x into dx. Clearly, you can see that the terms, the variables are separated. Now, let us go for integration. Integral dy would be equal to integral of 2x into dx plus integral of 1 by x into dx. Immediately you add the constant so that you do not forget here. Both of them are basic functions here. This is y is equal to 2 into x square by 2, and that you can see it is log x plus the constant. 2 and 2 can be cancelled. So, y is equal to x square plus log x plus the constant c. Take it as result 1. Now, this is the general solution. Since I want a particular solution here, how do you find? See, in the previous problem, it was given that x equal to x equal to 0 and y equal to 2. Here, you have to write one sentence. What is that sentence? Since, because it is a statement problem, some statement have to be written. So, since the curve is passing through, what's the point? 1, 1, you write now, put x is equal to 1 and y is equal to 1 in the result 1 here. Put x equal to 1 and y equal to 1 in the result 1, that means this one. So, let me write the value. Y is 1, that is equal to x square, that is 1 square, plus log of 1 to base a plus the constant c. Now, you know that log of 1 to any base is always equal to 0. That is 1 is equal to 1 plus 0 plus c. Now, 1 and 1 are cancelled, 0 is there already. That implies that c is equal to 0. So, c need not always have a number other than 0. It can become 0 also. Now, put c is equal to 0. Put c is equal to 0 in the first result. This is a general solution. Since I want a particular solution, I am substituting the value. So, what do you get here? Y is equal to x square plus log x. Okay. Now, is the solution, is a particular solution, of course. It is a particular solution. So, this is the procedure we adopt here to, sometimes I told you already, if it is given, given in the which form, if it is if the thing is given directly, as in the previous problem, writing the value x equal to 1, y equal to pi by 2, something like that, no? Then it is easier for us. If it is given in the form of a statement, naturally you have to carefully understand the problem and what is the value of x and what's the value of y. When point is given means first value, it's coordinates of the point. First value would be the x coordinate, the second value would be the y coordinate. So instead of giving the values of x and y directly, it may be given like this. Okay. Now these are the problems which have been solved using the variables separable form. Okay. Now this completes the first method of integration, first method of finding the solution of the differential equation. Now I am moving on to the second one. I told you this method where variable separable form, no, it is generally given for a 3-mark question. So again I am telling you repeatedly this one, for a 2-mark question, to find the order and the degree would be given, that type of problem. So order will be always there, degree may be defined or may not be defined, which I have explained in the earlier sessions. Now in the part C, 3-mark category, you can expect a problem, they just give you solve, okay, or it may given as in this particular problem, it may be given as a statement problem also. If the data is given directly, well and good. Otherwise, if it is given in the form of a statement, you just understand it correctly. Passing through means those are the values of x and y which have to be substituted to arrive at the particular solution. After getting the values, you substitute in the general solution, that becomes a particular solution. Now in the next session, I am moving on to the next method, which is called as a linear differential equation, which is given for a 5-mark question. Thank you.